Good afternoon, I'm Mr. Ish. You're looking here at Graph Movement Part 2 video, where we're looking at the previous video concept and we're bringing it a step further by 2 more examples. Again, remember vertex is in the form of h and k, and for each question we're showing the relevant equations at each step, given we are provided the very first one, and we have to show the vertices for each step. We are looking here at a cubic function which goes here to the origin. So the vertex of this, if you were to call this a vertex, we can do so, but it's not a true vertex in terms of a point. But we can say this as being the defining point of this. So let the defining point at the middle of your cubic function be represented by the word vertex over here. We're starting here with f of x equals x cubed with a proposed vertex at 0, 0, and then we have that movement. We see that this entire function shifts down by k units. Right over here is my vertex now, my new vertex, and what will be my function? It will be f of x is equal to x cubed, and we've moved down by k units. Direct movement down by k units, and my vertex or the central point right here will be 0, minus k. And then we shift over here, and we look over here that our function has moved towards the right by h units. In terms of the vertical extent, it's still the same. And here the equation must now be x minus h whole cube minus k, because this right here, minus h, represents a horizontal movement, but it still falls under that cubic aspect. So you have to keep that within the parentheses. Remember, a minus h, x minus h represents right, x plus h represents left movement. The vertex here must be what? It'll be h minus k. These would be like x minus y. It'll always be a value you'd find in the fourth quadrant, and that vertex is in the fourth quadrant. And then we come down over here. We see that the movement here is the same. There is no movement, except now there's a bit of a flip or flop of your curve. Your function has basically, if this was like an imaginary horizontal axis line, it has reflected across that. What we're seeing over here is this, a reflection across that imaginary horizontal. It will be minus x minus h whole cube minus k, and the vertex is still, of course, h minus k. Some may argue that there's a reflection here across a vertical line of axis, and the graph would look pretty much the same. Think about it. If you were to reflect this across a vertical line of axis, you pretty much have the same representation. So that doesn't matter. For this type of function, because it's an odd function, if you do a horizontal reflection or a vertical line of axis reflection, the end result in terms of the graph looks the same, but you can roll around with this equation form right here and you would be fine. So this question here has been completed. Alright, we end with this last question here for this part. Remember, in all of these diagrams, nothing is drawn to scale. We're looking here not at a function, because circles are not functions. They don't pass a vertical line test, but we have an equation form x squared plus y squared equals r squared. And I'm telling you here the center of the circle is at the origin, and we are already here with a good starting point. Now when we look at this next part, we've seen that the circle has shifted to the left. How can we represent that in terms of equation form? Well, it would be very well this: x plus h whole square plus y square is equal to r square, because there is no component in terms of y that we moved up and down, so there's no need to bring the k value, but we move towards the left and we have a plus h. Center here will be what? It will be minus h 0. That would be my center. From 0 to 0, 0, 0, we've gone to minus h 0. Then we look over here, we moved directly up from the previous point, we moved up. Now we have a movement here in terms of the k value. There's a shift here in terms of vertical, and we can present a good equation here. It'll still be x plus h whole square, because we're still, with regards to the origin, shifted towards the left. Y minus k. The reason why I'm bringing a minus k over here is because you got to think about it. We moved up in terms of y-axis, we're moving positive, and you must think of it as this. Equations are always y minus k or x minus h, and you're looking at it in terms of this. You moved up positive by plus k. Positive times minus retains a minus, so it must be a minus k over there. So don't get confused by these signs, because you can logically think them through. What will be the center over here? The center here is minus h, positive k, and there it is. And lastly, we have this movement over here. We suddenly moved this equation, this circle, and we translated it towards the right. Now what will my equation be? Well, how about we post it right over here on the bottom? It will be x minus h whole square, because I'm thinking about this as x minus but a plus h shift, so it becomes x minus h. And this right here will be y minus k whole square, because again it follows the fact that we have a positive k, but with a minus it retains a minus, is equal to r square. What's the center over here for the circle? Well, you guessed it, it'll be h, k, and that'll be it. So look through all of these movements. These are movements you should be comfortable with, and the equations that come about and the center or the vertices that come about, all of that is fair game material on the standardized subject math exam. Thank you for watching. Stay tuned. Have a nice day.